Alright, chapter 6.4 is less about substitution and elimination. If you don't know how to substitute or eliminate, you need to make sure you work on that, but it is just more about your ability to take the words and turn them into algebraic equations and then create a system. So again, if you had any issues with translation in chapter 1, this is where you kind of want to just make sure you understand you can actually learn it now. You've had a lot of experience, so it shouldn't be an issue this time around. The essential question just pretty much says, how many types of problems do I need to be ready for? Honestly, because there are a lot of problems that you're going to see that have systems in them, I'm not going to try to show you everything you're going to face. What I'm going to try to do is separate into two main categories that you're going to see. Again, they're not all the categories you're going to see, but after that, you just kind of go experience it like everybody else did and go from there. The two main types of patterns you're going to see, or systems that you're going to see, is comparison problems and standard problems. You're going to see problems where you take two companies or two anythings and compare them and see which one's better, and then you're going to have a standard problem where it's just pretty much setting up two equations and going from there. As I just stated, comparison problems are pretty straightforward. It's whenever you take two companies or two type of things and figure out when they're going to be the same. They typically have the format of being both of them in slope-intercept form, y equals mx plus b, y equals mx plus b. And of course you would solve by substitution. Again, this is all in your notes here, so make sure you get all that stuff down. But again, also remember when you solve this, because y is equal to mx plus b, that you simply take this portion, put it up there, and solve it. We are going to go over a quick example, but I won't solve it for the sake of time. A comparison example, again, talking here, is where you have a catering company that charges $18 per plate for their banquet services, and another catering company charges $35 to reserve and $3 per plate. They want to know where, at what number of plates, Trudy's is going to be the cheaper option. So again, what you want to do, because you know you're comparing two companies, is put your y equals. Notice that Rudy charges $18 per plate. Remember that the word per in our experience means you multiply 18 times a variable, so we're going to put y equals 18x for Rudy's. And then we come down and we say Trudy's Catering charges $35 fee. So again, here's the first thing, is that the $35 fee happens once. And because of that, you don't put a variable on it. But Trudy also charges $3 per plate. Again, there's that word per, which means that it should be added on to 3x. And so again, once that system is set up, you would take this part, put it up there, and end up with, and you don't need to write this, but because this is substitution, y can be replaced with 35 plus 3x. And then you would go ahead and solve that by subtracting your 3 and dividing by whatever else was there. But this wasn't made to be solved, but that's just pretty much what you're looking at. Alright. Standard problems are mostly simple, and they have a pretty general format. Unfortunately, there are some twists that can cause you to stare at the paper for a long time. They typically have the format of both being in standard form, and I do say typically because they don't always have both of them in standard form. And you will usually solve these by elimination. Again, make sure you put that down on your notes. Before moving to your examples, I want to discuss the two tricks that exist in standard problems. That way, if you bump into a standard problem that you can't solve, you can kind of go to your notes and see if something is missing. One of the things that you might see in a standard problem is a hidden total. And a hidden total just means that they don't tell you that it's a total, but you need to use it as a total. And so if you saw a word problem or application problem where it might say something about there were 80 students at the assembly, you need to understand that 80 students represents a total of students. And typically you're going to have two variables. Of course, if you're breaking students into two groups, you would have boys and girls would equal 80. So in a hidden total, you usually take that number and separate the two variables and pretty much add them up to make whatever that is. Some number of boys plus some number of girls added up to 80 students. If you saw a statement in a word problem that said 500 fans attended the game, again, 500 fans attended the game. Usually there are adult tickets and student tickets, which means that adults and students, again, that is a S, make sure you can see that as a S, but adult students and student tickets should add up to 500 tickets altogether. Again, adults and students made 500 fans that attended that game. So whenever you bump into a problem where you can't seem to find a second equation, look to see if there is a number that represents a total, and if you find one, that is what you do with it. Another thing you need to look out for is a multiple. Sometimes a problem discusses a relationship as a multiple. It'll say something like there were 9 times as many women as men. What that does for us is it gives us two options. It gives us the number of men is equal to 9 women, or the number of women is equal to 9 times the number of men. And it helps, especially until you get used to it, to write both of them and then think your way through it. Read back through and see which one there is more of. If it says that there were 9 times as many women, that means there were more women. And it doesn't make sense that you would take a big number here, multiply it by 9 to get a smaller number. You would usually take a smaller number, multiply it by 9 to get a bigger number, which is why you would actually use that one. Typically what's going to happen in a multiple problem, whoever has the most is going to be the variablist by itself. Since there were more women, it's going to be W equals 9M, not M equals 9W. Same thing here. If the length is 5 times larger than the width, we have two options. We have length equals 5W, or we have width equals 5L. So again, I would put this off on my scratch area, and then try to think my way through it. If the length is 5 times larger, that means that length is more, which means we want length by itself, which means that's not what we want. This is what we would use. If you can put that together with your formal training from chapter 1, then you're 99% of the problems, or you're ready for 99% of the problems that are out there. Again, just be sure to slow down and allow yourself to think. And remember that sometimes you have to abandon your initial idea to think from a different perspective. Don't be stubborn just because you think that your first idea of how to solve it is the best. Sometimes that can kind of drive you crazy. Let's look at 2 quick standard examples and wrap this thing up here. Talks about 2 family reunions attending the Chicago Bulls basketball game. The first family had 14 students and 7 adults, paid a total of $215. Second family had 11 students, 15 adults, paid a total of $325. So what you see here is, again, it's a standard example, which means you're usually going to have a nice, simple translation. 14 students means 14S plus 7 adults, paid a total of $215. That is family number 1. And then looking at family number 2, it had 11 students and 15 adults and paid a total of $325. Of course, right there, and you don't need to write it, we would multiply 11 up, 14 down, and solve using the elimination that we learned in chapters 6.2 and 6.3, or it's actually 6.3. So if you're having an issue with elimination, go back and fix that. But at least if you know how to set it up, you have the potential to actually answer that question the way you need to. All right. One more before we wrap this up. It talks about a school cafeteria selling 2 different kinds of wraps, vegetarian and chicken. The vegetarian wrap costs $1. The chicken wrap costs $1.80. Today they made $98.80 from 70 wraps sold. They want to know how many were vegetarian. Again, this is a system, and so we have to solve it. And what we're going to do is use the fact that we have 3 numbers that are talking about money and understand that usually goes together. In other words, $1 per vegetarian wrap and $1.80 per chicken wrap adds up to $98.80 altogether. And so we have our first equation. But when we look at for our second equation, we notice that there's no numbers that go around. There's just a 70 there. And this is where you have to think about 2 of the tricks that we talked about. 70 is your other number, but it doesn't really combine with anything. And so what you have to remember is that 70 wraps were sold. That is a total there. And so what you're looking at for your second equation is that vegetarian wraps and chicken wraps should add up to 70. Now, of course, if you were solving this, you would not put a 1 attached to V, so it would be V plus 180 C equals 98.80, and then V plus C equals 70, and of course from there you could switch that. That would cancel out your V's. Just remember when you do this that you would do 180 minus 1, because remember that that invisible number there is a 1, and that would help you out. Alright, but other than that, like I said, I'm not going to talk about the solving overall. Just make sure you're ready to do that. And again, if you have a question on one whenever you bump into it, just let me know so we can try to figure it out. You are experienced enough to solve applications of systems, but you have to be comfortable being mentally uncomfortable. Sometimes when you don't know what to do immediately, a student can kind of start to stress out a little bit. But just relax and remember that you do have all the information you need. You have all the training you need. just again, use your students, use other students, use teachers, use people to help you out to understand it. And when they tell you, just make sure that you actually write it down and do your best to remember it. But again, as long as you're okay not knowing immediately and understanding, you will eventually get it. Things will be fine. So good luck.